And welcome to Chapter 9. So today we are going to go over access control lists. So the access control lists are what really the beginning of setting up a firewall. We're going to have our router act as a firewall. What is a firewall? A firewall is like a security guard that sits in front of the building and has a list of entries, and every packet that comes in, I will check the list according to the IP address, the destination IP address, or the port number that you're supposed to be going with. If you're on the list, you are either permitted or denied, depending on what the list says. So it's just like a security guard. That's what an access control list is. We are going to create a list, excuse me, and then we are going to apply it on an interface, either fast Ethernet 00 or serial 000, and then we're going to have to say, should we apply it on the packets that are coming into the router or leaving the router? Okay, so remember, when we're talking about, so an access list would be sitting, for example, let's say sitting right here. This is the serial interface. In means coming into the router. Out means going out of the router. That's very important. If you put a security guard right in here and he's checking for packets leaving the router, that means anybody can come in from the internet, right? Because the security guard is checking people going out. This is like if you ever went one of those federal buildings and you have a security guard that's checking people in, and when you leave, you just leave, like in the airports too, right? If you switch the guy around and tell him, check the people that are leaving, not coming into the building, that's a major security issue. So the direction where you apply the access list is going to be very important. So what is an ACL? An ACL is similar to a security guard in front of a building. An ACL is an access list that the router will check either on the in or outgoing packets. What does it check? It checks the IP addresses, the port numbers, for example, and then looks up at the list to see if you are either permitted or denied, like a security kind of an issue. Remember, ACLs, somebody can pretend to be someone else and they'll have access. If you go wirelessly into the LAN, you can bypass the ACL, the access, the one on that interface. So there's a lot of security issues that we'll talk about some other time, but not here. All right, so if you remember from 203 class, the TCP conversation, first of all, you have to send in a sync signal, say hello. Remember, TCP is connection oriented. You say hello, then he says hello back to you, then you send an acknowledgement, a three-way handshaking, and then you start sending, that creates the connection. And then you start sending data. He says, okay, the data is good, send me more, and blah, 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 windowing and acknowledgement technique. That's how TCP works. And you can use the sequence numbers when you're doing that, and you can use the port number for this guy to identify which packet is coming in, what application is being used, and so on. So packet filtering means really looking at the source IP address or destination IP address or the protocol, then look at the list to see if you are on the list, if you are permitted or denied. When you create an access list, there is going to be an implicit deny at the end regardless, so that if you created an access list that has all deny statements, by default, everybody's going to be denied because the last statement denies everybody anyway, right? So what happened is once you come in, once the frame comes into the router pulls the packet out of that frame, and if there is a security guard, an access list on the interface, it says, okay, wait, let me check your IP addresses and the port number. He looks at them and he looks at the list. He says, you're denied. Sorry, the list says you are supposed to be denied. If the first entry doesn't check, he keeps checking one entry at a time in the access list. And if you are permitted, then you are permitted. And by the way, once you match an entry, either permitted or denied, you don't check the rest of the entries in that access list. You just stop and take action. You know, if you denied them, then you denied them. If you permitted that packet, then it's permitted, right? So inbound means going into the router. Outbound means leaving the router. Has nothing to do what the router is connected to. Remember, the access list is inside the router. I get some students being confused that, in means into the LAN. Has nothing to do with the LAN. In means into the router. Okay, be very careful when you are applying it because, like I said earlier, if you apply the access list in the wrong direction, that's going to be a major security breach. So be very careful. All right, there are two types of access lists. There's a standard and an extended. A standard list only looks at the source IP address. For example, here's an example. You say access list number 10. This is just a number that you are giving to the access list, meaning that you probably create 9 before. This is just the title of that access list. And the first statement in it is going to say permit 192.168.30.0, and this is the wildcard that we talked about from the last chapter, which is the inverse of the subnet mask address. Remember, this is like the /24 inverse /24, right? You take the 4255s minus /24, you get that. So this will permit anybody's source IP address that starts with 192.168.30, and it doesn't matter what's your last. See, this 255 means it doesn't matter what the last digits are. So if your source IP address starts with 192.168.30, then you are permitted. That's it. If it doesn't, then you are denied. Why? Even though there's nothing written underneath it, there's an implicit deny that would immediately denies your access list, denies your entry. If you placed it on the input, on the in, or denied out, for example, you can't leave the router. Extended list not only checks the source IP address of the packet that's coming in, but here's the source IP address and here's the destination IP address. Means anywhere, any destination. Doesn't matter what your destination IP address. And if you're trying to do port 80, which means HTTP. So this is allowing anybody that their IP address starts with 192.168.30 going anywhere trying to do HTTP, which is port 80. So this is the extended, allows more flexibility and more precise in filtering packets. Okay? Numbering and naming. Now, the numbers of ACLs in the ACLs, in the regular ACLs, for the standards, usually you use the numbers 1 to 99. So that means you usually create between 1 and 99 access lists. You're not going to create more than 100 standard access lists. There are additionals. You can go from 1300 to 1999. I don't know anybody that used more than 5 or 6, to be honest with you. Extended list goes from 100 to 199 or 2000 to 2699. It is best to use named access lists. And Cisco recommends that you use this because we don't use numbers anymore. It's much easier to use access name. Give it a name and forget about the numbers. And the names can be, they're really unlimited. You can come up with any name, and the name really describes what that access list is for, so it's a little bit easier. We'll go over these in a few minutes. Okay, the wildcard. We'll go over the standard list. Let me just go over, here's a list, and this is I want you to submit. Let's look over the standard access list. So I want you to type these in and submit them as homework. And there's more coming. So just start writing these up in Microsoft Word, of course. For a standard access list, you use the numbers 1 to 99, and there's the other range. 1 to 99 is plenty. It filters packets on the source IP address only. So it's going to look on the incoming packets. It's going to look at the source IP address, and then look at the list. Okay, where do you place this access list? You place it close to the source. So if you have a lot of routers around, you find out where the source IP address is coming from, and you go to that interface and apply it there. Is that clear? For example, let me explain to you what I mean by that. Let me go to some routers right here. Let's say the access list is, the standard access list is right here. Here. Let's say this guy is right here. You want to go, these are the 192.168.10, right? So you apply it right here, close to the source. Because, actually, I'm sorry, close to the destination. Where's the destination? Where you want them to be denied? Let's say you want them to be denied here. So you place it right here, right? So that they'll be denied from entering this network. Even though their source IP address comes from here, but you deny them at the destination where you're trying to deny. For example, these people said, I don't want anybody from LAN 1, this LAN 1, coming into my LAN. So you create a standard list on R3, right, close to the destination, and you say access list number 10, deny, whatever, these guys, their source IP address. And you apply it on the out of this interface. Why do you play it? Because if you apply it here close to the source, what happened? The source IP address will be there, and therefore they can't even go anywhere, because they'll always be denied from going out. So, you place it close to the destination. Here's the example. Access list number 12, remember the number, you always write access list access dash list, and you write the number. This number has to be between 1 and 99. Then you write the statement permit or deny. In this case, we are denying. We are denying anybody that starts, their source IP address starts with 192.168.10 with a wildcard of 00.255, right? And then you say, all right, permit any. The next statement in access list number 12 is going to say permit any. Any means any IP address. If you don't write this word, permit any, remember, by default, everybody is denied. So you have to write permit any. If you don't match this, that means you're going to be permitted. That means if you are not from 192.168.10.0, then you are permitted. Then I go to interface fast Ethernet 00. Remember, this interface fast Ethernet 00 should be where the destination is, where the people don't want you, right? Or maybe it should be on wherever you want them coming in or out. Then you say IP access group. In other words, you go to that interface, and then you say IP access group number 12. In other words, please take the access list number 12, which has these two entries, this entry and this entry, and please apply it on all packets that are coming into the fast Ethernet 00, right? Or you can change this word instead of in, into the out. Okay, so that's just a regular standard list. Very easy to do. We'll try that in our example later on today. All right, so let's continue. We wanted to look at the wildcards, I think. Yeah. So taking a look at the wildcard, I know we discussed it. The wildcard is considered to be somewhere the inverse of the mask, right? The reason for that, now a wildcard 0 means match, 1 means don't match, you remember. Okay, so for example, if you say here is 192.168.1.1 and you write a wildcard of 0, that means 8 zeros, that means every bit in here has to match in the incoming packet. So if you write 192.168.1.1 with a wildcard of all zeros, that means the IP address have to be exactly 192.168.1.1, right? If you write all ones, that means, and if you write this IP address and all ones means, it doesn't matter what the IP address is. That means ones means don't care. Ones, if you write a 1, that means you don't care what the bit is. If you write a 0, that means you care what the bit is. So here, For example, here you write 8 zeros here, 8 zeros, 8 zeros, which means you want to make sure that the incoming packet matches the number 192, 168, and dot 1. The last byte, which is 255, means right here, it doesn't matter what that incoming packet has on the last byte. It doesn't matter, right? Once means doesn't matter. Okay, so for this case, in this case, here's another example. 192 matches, 168 matches, and 15 means from 16 to 31, the first 15 bytes, and then 255 bytes, right? Here, you want to match from 168, from one more byte, all the way to 255. Okay? How do you calculate the wildcard like we did it before from the last chapter? You take 4 255s minus the submop mask, and then you get your wildcard. You can think of it this way. For example, if you get the wildcard, you're saying you're allowing the first 15 addresses starting with that number. For example, if you have, here I'll show you. Well, I'll show you in a few minutes what I'm talking about later on. Now, if you write 192.168.10.10 with a wildcard of all zeros, you can use the command, because that means you want every single bit 192.168.10.10 to match. So instead of writing quad zeros, you can write host. Remember I wrote that in an example? So you can say permit host 192.168.10.10. Now if you write quad zeros with 4 255s, that means you don't care any. So you can change all of these quad zeros with quad 255s by replacing all of that with the word any. That's why I wrote the word any, means any IP address. Okay, so instead of writing here quad zeros, quad 255s, all of that can be replaced with the word any, the keyword any. And instead of writing quad zeros, because you want exactly this host, you can say permit host and just one IP address. All right, the guidelines for creating ACLs. Now, you always should place your ACLs on the incoming packets that's coming from outside, border routers or routers that are between decisions between two networks. Wherever you need them to deny packets that are coming or leaving the routers. For example, you can place them on the serial interface going out if you don't want anybody from doing HTTP, for example, or sending emails or receiving emails, uploading and downloading files. You could do that as well, right? So the 3 Ps, the guidelines, you should have one ACL per protocol. So if you have IP, just have one ACL on that interface, one direction. So for example, on a fast Ethernet interface, for incoming packets, you should have one IP. There's only going to be an IP, one packet. In other words, there should be one security guard looking for packets coming into the fast Ethernet interface, only one. And one security guard looking for packets leaving. So on one interface, you could have 2 ACLs, one for coming in and one for going out. Of course, IP, right? Only IPs. Excuse me. Now, the ACLs, the best practices, is because you want to create the access list according to the security policy that you have. You don't just make up your own or just go and listen to whatever the users want or don't want. According to the security policy is the best way to go. So this way you don't get a headache. Everything is written down and you know exactly what needs to be done. Make sure you can write a description of why you're doing this, and write down this is supposed to filter out HTTP between 12 o'clock and 2 o'clock in the afternoon, Monday to Friday. And that's why you're doing it, because of their lunchtime or whatever. So write a description. Don't just write an access list, because it'll be very difficult to figure out why you're denying certain people from accessing certain resources. So you got to be very careful. And the best thing to do is don't go to the router and do it immediately, because that immediately takes effect. So what you want to do, go to Notepad, write all the access list, test it out before you implement it. Okay? So that's the best thing to do. Where do you place your ACLs? Remember, standard ACLs are always placed close to the destination, but extended ACLs, you place it close to the source, right? And so here, let's look at the extended ACLs. We talked about the source ACLs. Now let's go, and here is your next one that you have to write down for homework. The extended ACLs. You're going to use the numbers between 100 and 199. Extended ACLs looks at packets, looks at the source IP addresses, the destination IP addresses, and the port numbers. And then you're supposed to place it close to the source. Okay, just give me a minute and I'll be right back. Okay, we are back. So let's go back to what we were saying before. And going back right here. So with extended list, you want to place it close to the source. And why do you want to place it close to the source? Let me show you. If we go back here, let's say this is the source, and this is your destination. And somewhere is your destination. Let's see, here's the extended. So if this is the source, I'm going to take a look at your source IP address, your destination IP address, and your port number. Let's say you do an HTTP. Deny him right here. Why should you let him leave and create traffic, and then ultimately, if this was the HTTP, it's going to be denied anyway. So deny him at the source. With the standard list, you can't deny him at the source, because you're looking only at his source IP address. If you deny him, that means he won't be able to go anywhere. So remember, with extended list, you place it close to the source. With a standard list, you place it close to the destination. Here's an example. Access list 120. Remember, the number has to be between 199 and 100 and and 199. Then you use the word deny, and either could be permit or deny. Now here's something different. Here you can either put the fourth layer protocol, either TCP, UDP, or ICMP, depending on what you're trying to do here. Depending on what this is. If this is a TCP, which is SMTP, this is email, port 25, then you write TCP. If this is going to be a UDP, for example, 68, then you use UDP. If you're going to do pinging, then you write ICMP, because that's an ICMP protocol. So you have to write here TCP, UDP, or ICMP. Then this is the source IP address with the wildcard. This is the destination. This is the destination IP address with the wildcard. And this is the port number. See the 63 right here, wildcard? This says you are denying the destination as long as their IP address starts with 127.16.100.65 and just add 63 more addresses, right? To 127. They're denied. That's what that .62 means. That's what that wildcard does. Remember, there's a space here. And then you say permit IP any. You have to say IP. If you just write TCP, permit TCP any, that means you're permitting any other TCP protocol, but not UDP protocols and not ICMP. In other words, you still cannot ping if you just write this, if you write TCP here. Permit IP any means any IP packets is allowed after that. Then you go to the interface and you say IP access dash group, the number of the access list that you created, and now we're placing it on the out. Okay, so write this down, these notes. If you have any questions when you come into class, please ask, and I'll be more than happy to clarify. All right, let's continue. Let's continue with the slides. So extended list, you place them close to the source, right? And here's a typical extended list. This is really a standard, right? Not an extended. So here you are permitting 192.168.10. And the deny any, you don't even have to do this because that's an implicit deny anyway. All right. So here you deny host. You can deny a subnet /24, /16, or a /8. Right? That means this one you are permitting anybody that starts with 192. This one you are permitting anybody that starts with 192.168. Here you are permitting anybody that starts with 192.168.10. Here you are permitting with anybody that starts with 192.168.10.10. By the way, you should set up your access list with the more explicit, like this, and then go down more generalized. Because if you put this first and you want to deny the host, he will be permitted before this guy is denied, and that's not good. All right. So I just showed you how to configure it. If you want to write a comment in your access list, you use the word remark to do that for you. All right. So here's where you use the keyword host to do that. And this is how you apply it to an interface. You go to the interface and you either apply it on the in, coming into the router, in this case, right? You're denying this host, so this host cannot leave his LAN. Everybody else can, right? Okay, named access list. We'll be able to do that in a few minutes. Here's an access list, named access list. For example, you have to start the command saying IP access list. Let's take a look at how to create named access lists. Let's go back to the notes. Okay. And here are the nodes for named access list. You don't have to use them. So from now on, even though you learned how to do source and destination, standard and extended, we're only going to do named access list now on, because IPv6 access list only uses named access list, no numbers. So might as well start using that even with IPv4. And just get used to it, and that's what you get tested on anyway, named access list. This is how you do it. You always start with the word IP access list, -list, and you either use the word extended or standard. So I just use the word extended, and you give it a name. So the named access, and the name usually in capital letters. Not usually, you should be in capital. So I just called it filter. And then you write your first statement. You don't have to write IP access list again. And the first statement is going to say deny TCP this host 192.168.10.3 going anywhere equal 80. So what am I doing? I'm denying host 192.168.10 from going to any destination doing HTTP. So this guy cannot do HTTP. Can I get on the internet to any website? Right? And then I say permit IP any, permit everybody else except this guy. Now, where do I want to apply it? I go to the fast Ethernet 00 interface, because he's located in there, and I say IP access group, please take this filter, access list that I just created, and apply it on the packets that are coming into the router. So when this guy comes in, he's going to be denied. Right? Much easier to create a named access list. Okay, back to the slides. So you can edit now the standard list numbered. It's much easier now. By the way, the best way to edit them, because when you create a named access list, they're going to get numbered like this, 10, 20, 30. Now you can insert something in between. So for example, if you wanted to insert a line between these two. You can write 15, permit, blah, 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 whatever you want. With the numbered access list, you can't do that. You have to create the whole list from scratch. What I usually do is I just put everything in Notepad and I create everything in Notepad. And I can insert, delete, do whatever I want. And then when I'm done, I just copy and paste into the config mode and I'm all good. All right? So you can do that very easily. Show access dash list shows you all the lists that you have and what's inside those lists. What are the entries in that list? There you go. There's another example of the named access list. Show IP interface. It tells you if you have any. Show IP interface on the serial 000 in this example. Show you that there is an access list number 1 on outgoing, right? Here's another example. 18 matches. The sequence numbers we talked about already. On the VTY line, right? Now this is a little bit of a different. How do you create an access list for somebody that's trying to telnet? So let's talk about that. Let's go back to the list. More notes. On your notes. And now I'm going here is on the VTY lines. So remember, let's say you wanted to telnet, right? And usually when you telnet from home into your router. You type in telnet space, the IP address of that interface that you're trying to reach on the router. You hit enter, and you're going to be prompted for a password. You type that password in, and bingo, you are in. Now, what if somebody got your password? Most likely they're going to go home to their house and telnet from their house. So now we're going to do another layer of security. I'm going to tell the router, listen, when somebody telnet, please check his IP address. Make sure the source IP address is okay, even before they type in the IP, even before they write their password. So we're going to create an access list. Here is an access list called telnet. And I'm going to say permit anybody's IP. We use a standard list, by the way, because I'm only checking the source IP. Although you can use an extended, though. It should be an extended because it's really doing telnetting. So let's say we're just using a standard list. Permit anybody that IP address starts with 192.168.10, right? And then deny everybody else. Then I go to the line VTYs, put in the password like we always do login, and then you say access class, the name telnet on the end. So that means before I even prompt you for a password, I'm going to check your source IP address. If it's not the same, you're out. I don't even need your password. But if you are okay, then you got to prompt it for a password. Is that clear? So that's 2 layers of security. This is how you, remember, how do you apply it? You say access dash list. I'm sorry, access dash class. It's not IP access group. Be careful. Okay? By the way, the capital letters, ignore them. This has only come up because I'm typing these in Microsoft Words. Okay? And by the way, it's probably better to do SSH. Remember how we did that? You create a username, create the crypto key, remember that? And then you say transport SSH. That's even more secure because now the data is, because your packet, not only the 2 layers of secure, but also that the data that you are transferring from the source to the destination is encrypted, right? So SSH is even more secure. But we'll practice telnet also later on. We're going to do a packet tracer. So there's a packet tracer where we test all of this stuff out. But we'll do that in a few minutes. Okay, so let's continue with the slides. So here is the securing a VTY port, right? So this way, here they're doing SSH instead of telnetting. So you can use an access. Here's a typical extended access list. 23 is telnet. 21 and 22 is the data, FTP. By the way, if you want to deny somebody from uploading and downloading file, you got to deny or permit 2 ports, port 21 and 20. By the way, you can use the port numbers or you can use the keywords instead, whichever. And by the way, this is the destination port number. You could have a port number right after the source right here. Remember, this is the destination with the port number. If you leave this empty right here, this is a port number for the source. If you leave it right here empty, that means it doesn't matter what the source port number is. In other words, if you put 23 right here, that's not good. You are not permitting telnetting. Right? That's not good. It has to be on the destination part, which is all the way at the end. All right. So here are a typical extended list being applied to the interfaces. Oh, by the way, here, port 80, you are permitting TCP 192.168.10.0 network going anywhere doing port 80, right? And then you are, that's an access list, and another access list permitting port 443. That means you are allowing anybody inside this network to leave, right, 192.168.10.0 to do HTTP, and port 443 is HTTPS. So anybody can do HTTP and HTTPS. Now, what this access list number 104 says, if any, no, the source IP address is any, and the destination is 192.168.10.0, and you place it on the incoming, the 144, which means, and what's this established mean? That means anybody that comes in from outside, I'm going to look at your packet. If your packet says that the connection was established from inside, then you're allowed back in. Otherwise, you're going to be denied. This is very important because what that means, if a connection is from was initiated from outside, your packet will not be allowed into the network. Only packets that were initiated from inside are allowed to leave and come back. In other words, if let's say you did HTTP and you went to yahoo.com, and when you are coming back, that means before you leave, you're going to mark yourself, say, I'm leaving. And they'll know that you are leaving, and when you come back, they'll check and make sure, okay, the connection was established from here. They are allowed the packet to respond from yahoo.com to come back in. But if somebody is trying to come in from outside, initiated the connection from outside, that access list will deny it. This can prevent a lot of attacks from outside. Okay, so you can put the 103 on the coming into the network, coming on this interface coming in. And usually I put the 104 right here on the serial port. Right? The 104 should be on here coming in. Yeah, this is wrong. 103 should be on the out right here, and 103 should be on the in. It's the other way around. Because the establisher is going to be looking at people coming from anywhere. That's the source IP address, and your destination is 192.168.10. So 104 should be placed right here, looking at packets coming into the router on the serial port. And the 103 should be right here coming into the router. That's fine. But 104 should be right here on coming in. Why? You could place it on this interface on the out, but that means the packet went right through the router and got here. That's not good because you want to prevent it before it goes through the router. This is okay, but I think it should be placed on the serial coming in. It's better because you want to deny any connection that happens from outside. All right, so here's a typical example denying FTP. If you want to deny FTP, like we said, you're going to deny 2 ports, FTP and FTP-data, which is port 20 and 21, right? Here we're denying, here we did 2 of them, right? The HTTP and HTTPS and the establish command, right? And here's to verify the extended list. You can type show access dash list. We'll do that for you. You can edit the access list. You can do it, use text editor. That's the best way to do it. Forget about the sequence number. Put it in Microsoft, not Microsoft, Notepad and edit everything that you want. It's much done better that way. Even though there's an implicit deny at the end, it's best to write down, by the way, deny any. So this way you'll remember that there's always an implicit deny at the end. Okay? Remember, incoming packets should be on the interface. Outgoing packets mean leaving the router. Okay? All right, so logical what happens with the ACLs? As soon as a frame comes in, I check the destination MAC address, make sure that that packet is for me as a router. Then I open up the frame, pull the packet out. If there is an access list, then I go and check the access list, make sure it's not denied. Or then, if it's not denied, then I can look up the routing table and send them out or send them in or whatever. Okay, that's really the logic that happens on an ACL. Same thing with the standard list and the extended list. Let's look at some troubleshooting errors, and then we'll go into Packet Tracer and look at an example together. All right, so here's an access list. This host, 192.168.10.10, has no connectivity to 30.12. And the access list is placed right here on the incoming. Why? Well, look, deny TCP 192.168.10.0/24, and the destination is any. So that's why he's denied, because the first statement denies him, and it matches. I don't even check the second statement, right? Even though if the second statement says permit them, and that statement says also permit them, he's denied out of the very first statement. It says deny TCP, so this guy cannot do any TCP going anywhere, right? If his IP address starts with 192.168.10, that's the reason. Okay, because he matches the first one. Let's look at the next error. It says 192.168.10.0 network cannot do TFTP, and it's placed right here. 2FTP with this guy cannot, upload and download file from PC3. Why is that? It's supposed to do that. Well, here you're denying TCP, doing telnetting, so that's fine. Has nothing to do with TFTP. You're denying TCP from doing SMTP. That's fine. That has nothing to do with FTP. And he says permit TCP NE. Well, he should be permitted, right? Wrong, because you said permit TCP any. See right here, and TFTP is not a TCP protocol, it's a UDP protocol. So if you were to write IP any, it would have worked, because IP comprises TCP, UDP, and ICMP. Otherwise, you're going to have to type in permit UDP any again in addition to that for it to work. All right, here's another problem. Network 11.0 can telnet. So this 11.0 network can telnet into 30.0 network, but is not supposed to. Remember, this is placed on the IM here. Well, look where the telnet is. It's at the source IP address, not at the destination. So this telnet is supposed to be here. So when I check the destination telnetting, I say, hey, you're allowed to go, because the source is never really checked. Is the destination says telnetting is what you're trying to deny. Here, if you're trying to telnet into your own LAN, which is wrong. So the first one ignores it, the second one ignores it, and then you are permitted because it doesn't match the first two. Remember, if you put the telnet over here, then you would have been denied. That means in the statement you did something wrong. 30.12. 30.12 is able to telnet to 31.12. And that should not be allowed. And why is that? Well, deny. It says deny TCP host 30.1. Well, he's not 30.1. That doesn't match, right? Immediately. And then he is permitted. And that's the problem. Instead of writing 12 right here, you wrote 1. And finally, this is on the input. It says 3012 can telnet into 3112. So 3012 can telnet into here. But look where it's placed. It's placed on the end. So when this guy comes in, the security guard right here is looking for packets coming into the router, not leaving. So this guy can go right in, and because the access list is looking for packets coming into the router, not leaving. So that's the problem. It's where you are, the direction of the access list is wrong. It should have been on the out instead. Right? All right. The access, okay, so here's what we're going to do. Let's go to Packet Tracer now, and we'll come back to, we'll come back for this later on. We'll finish out the slides. I want to give you an example doing this in Packet Tracer. So let me start Packet Tracer. And then we'll take a look at, by the way, IPv6, which is very, very easy. I don't think we wouldn't have to configure IPv6 ACLs because they're pretty straightforward, to be honest with you. All right, so let's see. Where are we here? Packet Tracer is still booting up. We'll do a quick one, by the way. We'll just do a couple of examples. Here we go. Let's let me grab a 2811 and okay, and let's say grab 2 PCs. Here's one PC right here. Here's another PC, and you know what? Let's grab a server, an HTTP server. Okay. And let's put the server right here. Let's get 2 switches, 2960 switch right here, one, and here's another 2960 switch. Let's connect them straight through cable. Fast Ethernet 01, another straight through cable, and another straight through cable to the router. Fast gigabit 00. Is that the 20? Oh, I put in the 29.0. You know what? Yeah, leave it at 29.01. It's okay. You know, no. I don't want to confuse you. I told you to bring in a 28. Let's bring in a 2811. I screwed up. Sorry about that. Let me go back to the routers and bring in a 2811. There is a 2811. And I'll take in the straight through cable, Fast Ethernet 03 to Fast Ethernet 00, then from Fast Ethernet 01 to the switch. You know what? We don't even need a switch. Okay, it's all right. What the hell? And then I go from 02 to the server. Okay, let's say this is going to be. Quickly put in the IP addresses. Let's assume that this is 192.168.10.2. Make it a /24. That the default gateway is 192.168.10.1. Let's say this will be .3. 192.168.10.3/24, 192.168.10.1 is the default gateway. Let's say the HTTP server is going to be 192.168.11.2/24, 192.168.11.1. That's the default gateway. Let's go in the router and just configure it. Say no. config T. I'm sorry, EN first. Then config T. Host name R0. Say no IP domain lookup. Okay. Let me go to interface fast Ethernet 0/0 and say IP add 192.168.10.1 with 255.255.255.0 and no shut. Okay, let me go to interface fast Ethernet 0/1 and say IP add 192.168.11.1, right? 255.255.255.0. No shut. Okay. Now, I want to, you know what I want to do also? I want to create a DNS server too. So let's go in and get a DNS server, put it in this LAN. Okay, and connect it. Go fast Ethernet, fast Ethernet 04, click on it, go to desktop and give them the IP address first. It's going to be 192.168.10.4 because we use 123, right? /24. His default gateway is 192.168.10.1, right? Let's go and close that. Let's go to this server right here. By the way, this server is going to be called, I'm just going to change the title of it so you'll know what to. This is going to be the www.netw205.com server, and this guy is going to be called the DNS server. Just give it a title so we know. Go to the netw205.com server, go to services, and go to HTTP right here. And just say here, let's say welcome to, remember we did this before, I think we did that in a different example. netw205. Okay, that's it. Make sure both HTTP and HTTPS are active. Close this. Go to the DNS server. Go to services, click on DNS. Make sure you activate the DNS service and say, if anybody gives me the name www.netw205.com, please give him the IP address. Give him the IP address 192.168.11.2. That's the IP address of this guy. Oops. That's the IP address of this server, right? Click on add. So now I have that, right? By the way, if it's an IPv6, you would type in, well, Packet Tracer doesn't do that. It will be the AAA. Okay, so now I have that. Now, by the way, I can go to PC0, close this, go to the browser, and type I can type www.netw205.com and hit go. So what happened is I went to the DNS server, got my IP address, and then I went to the router, and the router sent me to the packet, the World Wide Web server, HTTP. Then transferred the packet tracer. See, remember we wrote that in there and transferred back. PC1 is also going to be able to do the same thing, right? So type www.netw205.com. So he does the same thing. So here's what we're going to do. We are going to deny PC0 from doing HTTP, but PC1 will be able to. So we're going to do an extended access list. Now, unfortunately, because we only have one route, it's going to be close to the source. So we're going to do it right here, and we're going to apply it on the incoming packets on this fast Ethernet 00. So here's how we do the list. This guy will not be able to do the HTTP, but this guy will be. So I'll go in to the router, right? Make sure you are at the config mode. So let's say IP access dash list, and we're going to create an extended list, and yeah, because we're going to write a lot, so I want to make sure you, and let's call it browsing. Okay, that's the name of the access list. Now, what do I want to do? I want to deny excuse me, deny TCP, deny what? Deny the host 192.168. Deny this host from going to this host, which is 192.168. That's not 192. That's. Or by the way, you can say you don't have to specify from going anywhere, right? Equal port 80. So he cannot tell that anywhere, not only to that server, but to any HTTP server. By the way, he can do HTTPS because I'm only denying port 80. If you want him to deny for HTTPS, also just repeat the command and write 443. So now I denied them HTTP and HTTPS. Now I need to apply it. Where do you go and apply this? That's it. Oh, no. Then you're going to say permit IP from any source to anywhere. He's allowed to do everything else. So I'm only denying him to get on the internet, right? He can still ping that interface if he wants to. He can do whatever he wants. Now I go to interface, fast Ethernet 0/0, which is this interface right here. And I'm going to say IP access dash group browsing on the packets that are coming in. That's it. Now this guy will not be able to do HTTP. Let's see. So I'll cancel that out first. Let me go and try to do it again. So here's PC0, and we type in www.netw205.com, and there you go. And I got my IP address from the DNS server, but when I try to go there, the request timed out because I'm blocked. But if I go to PC1, let me close this. If I go to PC1 and I do browsing, it should work, right? Because he has nothing to do with it. At w205.com. Yeah, he works, but he can't now. All right, so now let's do this now. Let's say I don't want PC1. Well, I don't want anybody. Well, I should not say anybody. I don't want this guy to ping the router, but I want PC0 to be able to ping. So let's do an ICMP protocol. So I don't want PC1 to ping the netw205.com server, but still allow PC0 to ping it. So here we go. So let's create an exit. Let's create another access list. And, well, you know what? Let's do it the other way around because one per interface. I want this one, the server, to be able to ping these two, but not PC0. So deny the server from pinging PC0. So we're going to place it right here on the incoming packets, right? So I'm going to say IP access list. Let's call it extended again. And let's call it PING, just ping. Pinging. That's the name of it. Right? It has to be in capital. So we're going to deny the host 192.168.11.2. That's the server, the NetW205 server. Deny him from pinging host. Who is that? 192.168.10.2. Now you don't write equal. You just write here. Put a question mark. Oh, I forgot. Deny ICMP. Forgot that because it's not TCP. You have to write ICMP. ICMP, the host, 192.168.11.2, which is the NetW205 server, and host 192.168.10.2, which is PC0. And then if you just put a question mark, just write echo. You don't have to write the word equal. So write ECHO, and that's pinging. So now the NetW205 server will not be able to ping PC0. Now you have to say permit. Forget that because otherwise everybody else is denied. Permit IP any. Now I'm going to go to the interface fast Ethernet 0/1 and say IP access dash group pinging, right, on the incoming packets, right? So now this guy will be able to ping the other two, but will not be able to ping PC0 because he'll be denied right here, close to the source, right? Because it's an extended. So let's take a look. Let's go to the server, go to the desktop, and go to the command prompt, and let's see if we can ping PC0 first. Type ping 192.168.10.2. See, destination unreachable. But if I try to ping not .2, .3, it replies that this guy right here. Let's try to ping .4, which is the DNS server. Why? Time request out. There you go. It worked too. But he's not able to ping this guy. See? Now we can do pinging. Now, let's say I only want to be able to telnet into the router. I want only the DNS server, or let's say PC1 is the only one that's allowed to telnet into the router, nobody else. So let's do some telnetting. Remember? So let's go in there. So here's our next, because I only want, I'm going to do the VTY, right? I want PC0 to only be able to telnet into the router. So let's do IP access list. When you're doing telnetting, we're going to do a standard list. And let's call it telnet. We called it telnetting. Yeah, let's call it telnet. Telnetting, right? Now I'm going to say, because I'm doing standard list, I'll just have to use permit the source IP address, and which is 192.168.10.2. He's the only one that's permitted. I don't even have to type anything after that because that automatically denies everybody else. That's good. Now I go to line VTY 0 to 4, right? Let me put the password. Password Cisco. Let me put login, so it prompts you for a password. Then you say access-class telnetting in. Right? That's it. Now this guy will be able to telnet, but everybody else will not be able to telnet. So let's try it. So let me telnet. Use the IP address. You can use any of these two IP addresses on the router. Let's use the default gateway, which is 192.168.10.1. What's the password? Cisco. Then I'm in. I type EN. By the way, I can't because I didn't do an enable password. But I'm in. So I should have done this. I should have done enable secret Cisco 1. So now I type EN, and now I type Cisco 1, and I'm in. I can do show run, everything. I telnet it into the router. I can type exit, and I'm good. Now, if PC1, if he tried to telnet, let's say he stole your password, but he's trying to telnet into 192.168.10.1, he's denied. No one else, in fact, can do that. Right? So you can see that the access list on all the VTY lines are good. So please save this and submit that as homework as well, in addition to all the other notes that we've talked about. Back to the slides. Now with IPv6 ACLs, it's pretty much the same thing. With IPv6, we only do named ACLs. They work exactly like IPv4 does. There's no wildcards necessary, by the way. You just use the slash. IPv6 takes care of everything. So you don't have to figure out what the wildcard is, sub not mask, none of that. Just put in the IP address with the slash, and the IPv6 guys will do that. Instead of using, you use the command IPv6 traffic-filter to apply the it to the interface instead of IP access group. IP access group, IP traffic filter. Everything else is pretty much the same thing. So here's a typical topology. IPv6, right? Configured. We've done that already before. Access list command name. The permit and deny is pretty much the same thing. Okay. So here's a typical example. When you go to the interface, you say IPv6 traffic filter, and then the name of the access list that you created on the end. So they're applying it on the end. That's after you create an access list called No R3 LAN Access. That's the name of it. Just remember, you got to use IPv6 traffic filter, it's called. Not access-group. It's traffic-filter instead. That's really the major difference. Here's other examples of IPv6, writing the actual entries in the access list. Deny TCP, the IP address, you use a slash. There is no wildcards. You can use the subnet mask address here. Everything else is pretty much the same. So you're denying any source IP address from going to this global IPv6 address from uploading and downloading files, because you got to deny both. And you say permit IPv6 any. And then IPv6 traffic filter, the name on the incoming path. Here's another bigger example on restricting access, not only denying FTP. So you can take a look at that. If you want to verify IPv6 ACLs, just use the command show IPv6 interface on the G00, right? It will tell you which ones you have. Show access lists will do that too. And that's it. So it's a little bit more involved, this chapter. I know there's a lot of information. When we come to class, we can actually do a little bit more of this. We'll repeat some of this, and we'll put it on the physical routers. And needs a lot of practice to really get a good hands-on, to really grab a good understanding. And remember, reading the book, looking over the notes, and practicing is what makes you a professional. So please don't forget, read your notes. Make sure you comprehend everything that we did. Do the packet tracer that we did in here. Take your notes, look over. If you have any questions, write them down. And when you come to class, make sure you ask if you are not clear on anything. All right? So we're getting closer to the end. 2 more chapters and we're almost done. All right, so hopefully this was, again, it was an informative chapter for you. So keep up the good work, and I'll see you in chapter 10, right? All right, until then, God bless.